one thing I did want to talk about before we get started was that if we do have snow days in this class, like if we end up having something where we miss class, I don't know what the school policy will end up being, but I talked to you guys on the very first day about Math 3 as a full curriculum. We do not have wiggle room to even miss one day. So in the event that something happens where we have like a snow day that lasts a single day, the impact on us is that we then have to double up. Does that make sense? If we miss 2 days, that means we have to double up 2 days. If we miss 3 days, we have to double up 3 days. Okay? So if we, yes. The what? So that we don't have the dates because our school chooses the EOCs, they're not like assigned. Our school says like, hey, when they announce like the final schedule, the teachers find out the schedule like a little bit before you guys do. So I don't know it yet. It's not like something that's been announced already. I basically have blocked off like the last week and a half or so, just to say that's usually when it is. So I've made it so like my schedule stops about then. But I've made it like our Math 3 schedule of when we're doing our units, when we're doing our finals review, all of that is already every single day for the entire semester is already like mapped out. Yeah, Pete.
I don't know if this is just like what they have like hypothetically, but they put out like a save the date type thing and it had it listed for May 20th.
Okay.
So I don't know if that's it.
Yeah. That kind of fits. I think what I had planned out was that because I think the 27th is listed as like the last day of classes or something, but that fits like right in that window of when I was expecting that we would have like finals and things like that. So, anyway, yeah, so that's, if we end up having snow days, I'm gonna clear this with Dr. Davis, but what I would try to do, I'm just gonna lay it out there for you guys, I would try to have us continue working because that would be better than us to miss days and have to double up. As you can imagine, if we had to double up on a day, that would be a very fast pace if we needed to do that. So it would be better for us to try to go through the snow days than it would be to have to double up at some other time. So the way that we would do it is I would probably not host a Zoom class because I know that whenever snow happens, power can be iffy. So what I would try to do is I would just say, hey, I would organize it on Canvas. I'd put all the information together so it was easily accessible. But I would say, hey, these were the video notes that you would watch the night before so that your notes are set. And then here are the class notes that I've recorded in the past so that you can see extra examples. And I would say these ones you have to watch because you have to have these extra examples to finish the notes. Or I might say these are optional extra examples. If you already understood it, you're good. Like you are fine. You can just use the ones you already had. I will be available at this time to answer questions. Maybe I'll make a Zoom meeting optional so that if you want to hop on to get individual questions answered, you could. And then otherwise you could just do the work independently. Does that make sense? But what I would probably do is say, we're going to keep going so that we don't have to double up later because it really puts a lot of pressure on you guys to have to double up a day. Does that make sense? Because Math 3 does not slow down regardless of us having a snow day. And at this point, like I do have it completely mapped out and there's no good way to do it if we miss a day. And if we miss, the teachers were talking, we were celebrating birthdays and they were talking about like, yeah, we hope it snows on Monday and then it like holds on and stays cool and carries through the week and we just have a week off. And I'm like, I cannot do that. My Math 3 kids we cannot do that. That would be terrible for us. So I'm just letting you know if something were to happen, my plan, if I can clear it with Dr. Davis, is for us to continue going. And that's not because I'm a jerk. That's because I'm preserving your guys' sanity for later. So if I do that, it's not me being crazy. It is truly me preserving your sanity. Does that make sense? Okay. All right, let's do these notes. But whatever I do, I will communicate very well. I will communicate through Remind. I will communicate on Canvas. I'll make things very organized for you so that you will know exactly what you were doing. Okay? And as much as I can limit the assignments, I will to make sure that we can learn things and not feel overwhelmed as much as I can, but just make sure that we are getting what we need to get. Okay. So first things first, we have using stuff from factoring to solve quadratic. So if you have something that has been factored, it might look like x plus a where a is a number. Some factors look like that. Some factors might look more like this, where you have a coefficient for x, so it might look like bx plus c. And then over here, we would take the factors and we would make sure that that equals 0. That is how a problem should look in the factored form before you solve it. Yes. Yeah, totally. Absolutely. So the way that you can factor to solve is by something called the zero product property. So the zero product property works because when you multiply two numbers together, a product to equal 0, either one of the numbers or both of the numbers has to equal 0. Like 0 times 5 is 0, 7 times 0 is 0, 0 times 0 is 0. That's kind of how zeros work when you multiply things. So we're going to assume, okay, maybe it's the x plus a. Maybe this is the part that equals 0. And so in this situation, we would subtract the a to the other side if we wanted to solve for x. And so x would equal negative a. That would be one of our solutions.
What if it's not the first one that's 0?
Okay, then it would be the second one that's 0. bx plus c could equal 0. And then in this one, we would subtract the c over to the other side. bx would equal negative c. And then we could divide by b. And then x would equal negative c over b. Yep. So there's two solutions. So it's possible that this could equal 0, or this could equal 0, or both of them could equal 0. But that's what the zero product property means, is that when you solve by factoring, you take your factors and you set them equal to 0. That's how we know how to solve. Okay, so let's go ahead and take this problem and let's factor it to solve it. So you'll notice when we were factoring yesterday, when we were reviewing factoring, we had expressions, which means they were quadratics and there was no equal sign. So those expressions were not possible to be solved. You can't solve something that's not an equation. You can factor it, but you can't do anything else. These can be solved because they have equal signs. These are equations. Equations can be solved, okay? So this one, it equals 0. That's a good first step, is to make the entire equation equal 0, get everything to one side, and so it is. This is one of those regular trinomial problems. So we're looking for two numbers that multiply to negative 28 and add to negative 3. And don't shout it out. We'll say maybe we're a little bit rusty with some of the multiplication. So if we're a little bit rusty, we're going to go ahead and hit that y equals button on our calculator. And we'll do negative 28 divided by x. And then we'll hit second graph so we can see all of our options. And which option gives us negative 3? Negative 7 and 4. Okay. So now I'm going to write my factors, x minus 7, x plus 4 equals 0, because I have an equation today, not just an expression. And so these two factors look like the first version, which means if I have x minus 7, that solution is going to be x equals positive 7. And if I have x plus 4, that solution is going to be x equals negative 4. And there's my two solutions. All right, the second, yes?
I have the quadratic formula program on my calculator. Am I allowed to use that?
Do not use that.
All right.
No. Yeah, in theory, before the EOC, they should all clear your calculators, which we've taught them how to clear. Yeah, the math teachers have taught people, like the other teachers, how to clear your calculators. Whether they actually do it or not depends on who is administering your test. But you cannot use any programs that would be considered cheating. Yeah. All right. So for this one, the equation does not equal 0. So what do we need to do? Set it equal to 0. So how do I do that?
Do the thing where you multiply the thing by the thing.
So that's a smart aleck type answer, which is not helpful. That kills a baby wolf, actually, which we could start keeping track of.
I mean, I think this is right. Multiply this, like, you multiply.
It's a baby wolf dying over here. All right, so we're going to minus the 8x. We're going to do it real quick so the baby wolf doesn't have to die all the way. And then we're going to minus the 8. Minus the 8. There's the 0. So we have 10x squared minus 11x minus 8. That equals 0. And what type of factoring problem is this? Flood divide is our favorite. We love these. These my favorite. Okay. So how do we start it? Okay. And what do we get? I was frozen for a second. Okay, so multiply to negative 80, add to negative 11. What are the numbers we're going to use? 5 and negative 16. Okay. So 5, negative 16. So we have x plus 5, x minus 16. Okay. So we did the slide step. What step do we do now? Divide by 10. Okay. So the number that we slid is always the number that we divide. Okay. And what do we do with these fractions now? Before we bottoms up. Yeah, we have to reduce the fractions if we can. So 5 over 10 reduces to 1/2. So x plus 1/2. And then we haven't done that step yet. And then 16 over 10 reduces to 8 over 5. Okay, and then what's our last step? Yeah, now we can bottoms up. Okay. All right, so we have 2x plus 1 and 5x minus 8. Okay, equals 0. And so now, if we compare these to our 0 product property, these do not look like the first version. These look like the second version. Okay, so how do we take this and write it like the answer? What do we do? Okay. Okay, so we're going to do the opposite sign of this number and divide it by that number. Okay, so the opposite of this divided by that. So x equals, anybody know?
1/2.
You're close.
2.
Negative 1/2. Negative 1/2. And then what's the other one? 8 over 5. Positive 8 over 5. Perfect. So it still changes the sign, just like the other ones do. It just becomes fractions. Yeah. Okay. Where's your comfort level with that? We're okay? 4 out of 10? It's rusty. Okay. Well, we got a good example. Okay. Whew. Okay. Quadratic formula. We're going to write it down because we're probably a little bit rusty. Now, the good news is with the quadratic formula, we don't have to do what we did in Math 2. In Math 3, we don't focus on simplifying square roots. And we don't focus on having like exact answers as much. We do a lot more with just like plug it in the calculator, get a decimal. Okay. All right, so x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. Now make sure that you have this written so that the whole thing is divided by 2a. So this little line, it goes all the way past the negative b, okay? Now, the discriminant, the b squared minus 4ac, that's the part that's underneath the square root. So I'm going to write underneath square root. And the discriminant can tell us what types of answers we have, because when you square root different numbers, it gives you different things, right? So if your discriminant zeroes out, if it completely zeroes out, then you get rid of this whole part of the problem right here. You don't have a plus minus anything. You just have negative b over 2a. So if that happens, then you actually don't end up getting two answers because you don't get plus one thing and minus one thing to get two different answers. You just get one answer. You get one real root.
In other words, the curve vertex.
Yep.
Is like
because if you guys remember on the problems where you couldn't factor it, you would find the x-coordinate of the vertex by doing negative b over 2a. Do you guys remember doing that? Negative b over 2a to get the x-coordinate of the vertex? So that's where that comes from. Negative b over 2a. Okay, so root, we've learned that the word 0 means x-intercept. The word root also means x-intercept. So they would use the word 0 for the x-intercept because the y-coordinate, y represents the function. You know, it's like y equals the function, so they use the word 0. They use the word root because we're taking roots. So these are all just synonyms for x-intercept. Okay. All right. If the discriminant is less than 0, if you get a negative underneath a square root, what happens? Do you guys remember from math 2? What happens if you get a negative underneath the square root? Yeah, you get the i's, right? So if that happens, we would not actually have an x-intercept. Like if you graphed it, you wouldn't see the x-intercept. That would look like it would be, oh, you can't even see that. I was too zoomed in. So here's our picture. It would look like this. There'd be no x-intercept. So mathematically, we'd be solving for something, it wouldn't even be there. So we would still have two answers though, because we'd have plus or minus, right? You'd get like plus or minus the square root of like negative 57. And so you'd take the negative out of the square root, you'd put a little I in front, and you'd be like, I have two imaginary answers. Mathematically solved for them. They don't exist, but I found them.
Very cute.
They're imaginary. They're ghost x-intercepts. There you go. Yeah, Clevin. I support that. So we're going to say two imaginary complex roots. Well, in math, complex means it has a portion that's imaginary and a portion that's real. So complex means something very specific in math.
Why does complex mean like fractions? Fractions are pretty complex.
Because rational means.
Why is fraction?
You killed another wolf. All right. Next one. Yeah, I'm gonna take the sticky note down and make you, or I'm gonna put a sticky note up and you're gonna mark down how many wolves you killed today. All right, b squared minus 4ac, if the discriminant is greater than 0, if it's a positive number, then you can actually square root it and just get answers. And those are regular x-intercepts, those are what we expect to see. It could be a decimal, it could be a whole number, but those are like legitimate answers, okay? So we're gonna say two real roots. Okay, two real roots. And now I'm going to draw a little arrow down here because we have two situations. My arrow looks wonky. Okay, situation 1 is that you could be taking the square root of a perfect square. If you are taking the root of a perfect square, then your x-intercepts are going to be nice. They could be whole numbers. They could be nice decimals. But they're going to be nice square root, or they're going to be nice x-intercepts. So I'm going to write nice x-intercepts. So think whole numbers, nice decimals, nice fractions, recognizable numbers. Okay, they're going to be nice. The second type we could have is just you're square rooting regular numbers. You're square rooting 20. You're square rooting 37. You're square rooting 82. When you square root those, they're going to be funky decimals. You're going to square root it and be like, well, that's strange. Okay? So these are going to be funky decimals. This is the technical term. Anticipated that. All right, let's go ahead and solve two problems real quick. So, same thing. Before we even start plugging something into the quadratic formula, we want it to equal 0. So we're going to go ahead and take this 4m that's on the right, we're going to minus it over to the other side. So minus 4m minus 4m. So we have 4m squared minus 4m plus 5 equals 0. Okay? All right. So for our quadratic formula, a equals 4, b equals negative 4, c equals 5. Are we comfortable with that? Okay. So following the formula, x equals negative b. So the formula starts with negative b. So we're going to say negative of negative 4 plus or minus square root. Then we got b squared. Now anytime your b is negative, you have to put it in parentheses before you square it. If you don't do that, you will kill a otter. Okay? Don't kill any baby otters. Dr. Davis will be mad at you. Okay? Dr. Davis loves otters. We do not kill their friends. Okay? All right. So, negative 4 squared. Okay. B squared minus 4 times A times C divided by 2A. Right. So in the front, we have minus minus 4, which is 4. On the bottom, we have 2 times 4, which is 8. Okay, for the rest of it on the top, we use our calculator. Do not type the square root, because if we have an I, our calculator is going to get very confused. So we just type all the stuff underneath the square root, which is the discriminant. So notice, I'm being very careful not to kill an otter. Negative 4 squared minus 4 times 4 times 5. Comfortable? Okay. So the discriminant is negative 64. I'm about to have Math 2 flashbacks because anytime you see a negative, 64, anytime you see a negative here, you have to put your calculator away, and the rest of the problem has to be done by hand. Because your calculator cannot do the I problems. You have to do the I problems. Okay, so we are going to have to finish this one ourselves. Yeah, there's going to be some. Not a ton, but some. Okay, so when I see the negative, what should I do? Yeah, so I'm going to make it positive. and I'm going to stick an I in the front. Not in the front of the whole problem, just in front of the square root. Okay. And then, does anyone remember, what is the square root of 64? 8. Okay, so what we have right now is 4 plus or minus 8i divided by 8. Okay. Now, we can reduce these numbers if they all can reduce by something, but it's got to be all of them. Okay. They can all reduce by 4. Okay. So 4 divided by 4 is, okay, 8 divided by 4 is, 8 divided by 4 is, so we have 1 plus or minus 2i all divided by 2. And that is our answer. Yep, you could do 1 plus 2i over 2 and 1 minus 2i over 2. Yep. All right. Comfortable? Next one. How do we start? Add the 10. So 3m squared plus 10m plus 4 equals 0. So A is 3, B is 10, C is 4. Okay, so we have x equals negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. So I've got the negative 10 in the front. What do I have on the bottom? 6. Okay, and then for my discriminant, I'm just going to go ahead and plug this in and see what I get. 10 squared, I'm not worried about odders this time because I'm not squaring a negative. So 10 squared minus 4 times 3 times 4. And what is my discriminant this time? 52. So that's positive. That means I'm going to get 2 answers. That is a regular number. So what are my answers going to look like? Funky. Funky decimals. Okay. So whenever you see funky decimal answers on my paper, you're not going to see me write x equals. You're going to see me write x is approximately, which is a squiggly equal sign. You can write the squiggly equal sign if you want to. You don't have to. Okay, I will not mark you down if you don't. But the squiggly equal sign means, in math, I rounded my answer. Does that make sense? That's all it means. Okay, so to type this in on your calculator, you're going to type the green button, alpha y equals, and then number 1 is going to allow you to type this in like a fraction so that you can type it in exactly the way it looks. Okay, is everyone able to do that on their calculators? Alpha y equals? The y equals is how you normally graph. Yeah, alpha y equals. And now we can type negative 10 plus square root 52. Yeah, negative 10.
Where did you get the negative 10? Second x squared. Where did you get the negative from?
B is 10, and the formula says to start with negative b.
Where did you get the negative from?
The formula starts with negative b. Right. The square root is in blue, It is right above the x squared button. So to get the square root, you hit second x squared. Okay. So this is what it should look like before you type it in. Or before you press enter. Everyone got it? Okay. So our first answer is negative 0.465 if you round up correctly. Or you can write 464. This is called truncated rounding, where you just write the first 3 decimals, call it good. Okay? So 465 is where you round correctly, kind of round up, round down, that sort of thing. Cutting it off at 3 decimals and not paying attention to the fourth one, that's called truncated rounding. It's a legit way of rounding. Okay? So I don't like truncated rounding. It feels like cheating to me. So I'm going to go ahead and round up to 0.465. Okay? Now I'm going to take my up arrow. I'm going to go up to what I just typed so that it's highlighted. I'm going to press enter. And then I'll go back and change my plus to a minus. There's my second answer. Negative 2.869. Oh, thank you. These all should be M's. You might be getting an error if the minus that you used in the beginning was a subtraction sign on the side and not the little minus at the bottom. Yeah. So if you look, you can see this little minus in the front is a little bit shorter and higher up, and this one's a little bit longer and in the middle. Do you guys see that? Okay. Betsy, you want to bring yours up and I'll look at it? Switch all these to M's because I was using the wrong variable. Oh, you're using both minuses. So there we go. There we go. Uh-huh. Yes. Wait 1 second. I'm going to explain the assignment. And then yes, absolutely. So we are going to do an assignment that is reminiscent of assignments you used to do in elementary school called color by number assignments. And we are coloring Snoop Dogg. And this, my friends, this is not a gang sign. He's telling you he loves you. That's what that means. It means that I love you in sign language. Don't ask Miss Gray. She doesn't know any better. She doesn't know. Okay. So here's how it works, okay? You're going to take the assignment. You're going to write colors next to the problem. So you're going to say something like, okay, number 1 is going to be pink. Number 2 is going to be green. Number 3 is going to be blue. And there are, let's see how many problems. There's 16 problems, so maybe you'll be as specific as like light blue, dark blue. Okay. So you're going to write the colors next to the problems, and then you're going to sit down and you're going to solve the problems. Okay? So number 1. So then as you solve the problems, you're going to do number 1. And then when you're done with it, you're going to look down here and there's an answer bank at the back of the first page. Okay? So let's say the answer for number 1, I don't know, let's say maybe the answer was G. Okay? Then you're going to look and say, well, what is G on Snoop Dogg? G, it's the stripes on his Pittsburgh hoodie. So then the stripes on his Pittsburgh hoodie would be pink. Does that make sense? So when you are done, because you are choosing the colors, you're writing the colors before you get started, Snoop is going to look all sorts of crazy when you get done. Miss Rice, do I have to color Snoop? You don't have to color him, but that's part of the fun. Miss Rice, why do we have to choose the colors ahead of time? Because it looks cool. Okay? It's wild. Miss, okay, don't say anything bad about Snoop, all right? We will fight you, okay? Miss Rice, do I have to color Snoop crazy colors, or can I just rip the picture off and color it nicely at the end? Oh, I guess fine. I guess you can, okay? The most important thing is that as you're doing the assignment, you are checking the answers and making sure the answers are there so that you know you are practicing correctly, okay? That's the most important thing. If you want to do it as a color by number, you can. That's how it's set up to be done. But if you don't want to do it that way, you don't have to. I will not be mad. Okay? Any questions? Okay, the instructions tell you how to solve the problem. So the first set of questions are solved by factoring. The second set of questions are solved by the quadratic formula. Okay? Yes.
If it's not set up like this, when it tells you like what you want us to do, do you care which?
No. Normally I don't care, but sometimes, so if it's open-ended, then usually there's like one method that's easier, and I didn't want you guys to have to choose today. I just wanted it to be set up so like, yes, this is a factoring question, I don't have to worry about it, I just know I can factor, or this would be impossible to factor, quadratic formula is the way to go. I didn't want you guys to have to choose. I also didn't want you guys to be like, I suck at factoring, I'm going to do quadratic formula on every single problem, because that's not helpful either. So it's good to practice both. So factoring first, then quadratic formula. It would not be factorable. So you'd be looking for numbers that multiply to something and add to something, and you wouldn't be able to find them. Because problems that have imaginary solutions, they are not factorable, they are prime. That's how it works. Yeah. All right.